Time to head back to Visual Studio and make sure that we understand both string immutability and the string builder. I'm going to show you the string immutability in the same program class. It is not related to what we were building before, but let's do it quickly here. Now, without actually knowing, we have been working with string immutability, or we have at least been encountering it already, well, since the very beginning, since we used a string. When we were, for example, using toLower, we were getting back a copy. When working with strings, we're always getting back a copy. The original is never changed. And let me show you that, because that is string immutability. Now, let's create a few strings. Let's create string name and set it to Bethany. And let's create string another name. And let's set that equal to name. So I have two variables of type string, and they're both pointing to Bethany in memory. Because strings are reference types, they are stored on the heap rather than on the stack. If I now do name plus equals, so I use the compound operator again, and I say space Smith. For starters, this creates a new string in memory, but then using the plus equals, so basically using the plus operator here, is going to create a new string in memory, which is the concatenated version of Bethany and Smith. Let's verify that. So I'm going to write to the console, name and another name. Let us test this out. So as you can see, name contains now Bethany Smith. That is the concatenated version. And although we had another name point to name, it hasn't changed. It is still pointing to the original value name, because that object hasn't changed. Name, however, did change. It is now pointing to a new string in memory. Strings are reference types and they are never changed. That is what you see here, and that is what we get with string immutability. Now I can show you string immutability also, for example, with the toUpper method. I'm going to call toUpper on name. Let us verify what name and uppercase name will be. As we can see, name hasn't changed. That is still Bethany Smith. Although I did call toUpper on it, it hasn't changed. A new string, uppercase name, was returned, and that is what we see here. The original string, again, hasn't been changed. Now, I said in the slides, this will actually create a lot of strings. Basically, every change that we make on a string will create a new string. Now, that can actually result in a lot of strings being created. For example, take a look at the following code. I have an empty string here, indexes, and I'm going to create a loop that runs 2,500 times, and I'm going to attach the counter to the value of indexes. Every time that I do this, a new index string is going to be created. In other words, 2,500 copies of indexes are going to be created in memory. That might not be an ideal situation. Although C# will clean it up, we'll talk about garbage collection in the next module, it is not an ideal situation to use this approach. And it might actually be better to use the string builder, because using the string builder, we are not creating new copies every time. We're appending to the original string. Let me show you the use of the string builder. I'm going to create a new string builder. As you can see, it can't find it. We need to actually bring in a namespace for this. We'll talk about namespaces in the next module. For now, just hover here over the light bulb and click on using system text. We'll create our new string builder. We'll use its constructor. There we go. And now the string builder has quite a few methods to work with strings. And internally, the string builder works with a list, which makes for better memory use instead of creating always a new copy. Say that we want to create a string, and I'm going to use for that append. Append will let me append to the original string. I'm going to say here last name, and a colon, then a space. And then I do builder.append again, and I use here last name. In fact, maybe I should use append line here. Then I'm automatically going to include a line break. I'm going to do the same for the first name. And when I'm ready appending strings, then I can actually get the final string by saying on the builder, do a toString, and that will get me back the complete string. This is, in terms of memory use, a much better approach. Now, for small concatenations, you won't feel this anyway. But if you have a lot of strings, it might make sense to use this. Again, talking about that loop, doing the loop this way will actually be a lot better. I'm again using a string builder, I'm again using the loop, but now I'm going to append to the original string using the string builder. And in terms of memory use, this is a lot better.